Imagine stepping into a sleek, futuristic machine, pressing a few buttons and finding yourself in ancient Rome, witnessing the grandeur of the Colosseum. Or perhaps you'd prefer a journey to the distant future, mingling with advanced civilizations and exploring uncharted galaxies. This is the dream of time travel, an exhilarating concept that has fascinated humanity for centuries. From H.G. Wells' The Time Machine to the blockbuster Back to the Future series, the idea of journeying through time has captured our imaginations. But time travel isn't just the stuff of science fiction. Scientists have pondered over its possibilities, delving into the mysteries of the universe to uncover whether we can truly navigate the fourth dimension. And then there are wormholes, those enigmatic portals that might serve as shortcuts through space and time. Picture a cosmic tunnel that connects two distant points in the universe, allowing for instantaneous travel. The allure of time travel and wormholes lies in their promise of exploration beyond our wildest dreams. Join us as we dive into the science and fiction behind these cosmic adventures, revealing the secrets of the universe and igniting our curiosity for what lies beyond the stars. At its core, time travel is the concept of moving between different points in time, much like we move between different points in space. Imagine time as a river, flowing continuously. Normally, we drift along with the current, experiencing events in a linear sequence from past to present to future. Time travel, however, is like hopping onto a speedboat and racing upstream or downstream, reaching destinations in the past or future in the blink of an eye. This idea has been a staple of science fiction for over a century, but what does it really mean to travel through time? Time travel can be imagined in various ways through a machine, like in The Time Machine, via a portal, as seen in the Doctor Who series, or even through natural phenomena, as suggested by some scientific theories. The key idea is that these methods would allow us to access moments in the past or future, offering a glimpse into different eras and potentially altering the course of history. Understanding time travel requires a shift in how we perceive time itself. To grasp the science behind time travel, we must delve into the theoretical foundations laid by Albert Einstein. His theory of relativity, particularly the concepts of special and general relativity, revolutionized our understanding of time and space. According to Einstein, time and space are intertwined into a single continuum known as spacetime. This means that time is not an independent entity, but is affected by the presence and movement of matter. Einstein, special relativity introduced the idea that time is relative, meaning it can vary depending on the observer's speed. For instance, the faster you travel, the slower time passes for you relative to someone at rest. This phenomenon, known as time dilation, has been experimentally confirmed through precise measurements involving high-speed particles and atomic clocks on fast-moving aircraft. General relativity, on the other hand, extends these ideas to include gravity. Einstein proposed that massive objects like stars and planets warp the fabric of space-time, creating curves that affect the flow of time. By manipulating the speed at which we move or the gravitational fields we experience, we could theoretically alter our passage through time. While time travel often conjures images of machines and portals, wormholes offer a different kind of cosmic adventure. Imagine the universe as a vast sheet of paper. If you wanted to travel from one point to another, you would typically move along the surface, covering the distance between them. But what if you could fold the paper, bringing the 2 points together and creating a shortcut? This is the essence of a wormhole. Wormholes, also known as Einstein-Rosen bridges, are theoretical passages through spacetime that connect distant regions of the universe. They are like tunnels with two ends, each located in different parts of spacetime. These ends could be in different places in space or even different times, making wormholes potential gateways for both spatial and temporal travel. Think of a wormhole as a tunnel through a mountain. Instead of going over or around the mountain, you pass through it, reaching your destination much faster. These cosmic shortcuts could open new frontiers for exploration, offering a tantalizing glimpse into the hidden dimensions of spacetime. The theoretical existence of wormholes is fascinating, but how might they actually work?
To understand this, we need to consider their structure and the challenges involved in creating and maintaining them. A wormhole consists of two mouths connected by a throat.
To traverse the wormhole safely, the throat must remain open, which requires overcoming a significant obstacle: the immense gravitational forces that would naturally cause it to collapse.
One proposed solution to this problem is the use of exotic matter. Unlike ordinary matter, which has positive energy density, exotic matter would possess negative energy density.
This negative energy could counteract the gravitational forces, keeping the wormhole stable and open.
Creating or finding a wormhole would also pose tremendous challenges. we would need to manipulate space-time on a scale far beyond our current technological capabilities.
This might involve harnessing the power of black holes or advanced forms of energy, tasks that are currently beyond our reach. If we could unlock the secrets of wormholes, it would revolutionize our ability to explore the cosmos and perhaps even travel through time. While wormholes and time machines remain theoretical, time dilation is a real-life phenomenon that brings us a step closer to the concept of time travel. Time dilation occurs when time moves at different rates for observers in different conditions, particularly those involving high speeds or strong gravitational fields. This effect is a direct consequence of Einstein's theory of relativity and has been confirmed through various experiments. One of the most famous examples of time dilation is the twin paradox. Imagine two twins, Alice and Bob. Alice stays on Earth while Bob travels on a spaceship at near light speed. When Bob returns, he finds that less time has passed for him compared to Alice. This means Bob has aged more slowly, effectively traveling into the future relative to Alice. Time dilation also occurs in the presence of strong gravitational fields. For instance, clocks placed in high-altitude satellites tick slightly faster than those on the ground because they are farther from Earth's gravitational pull. This effect is taken into account in the operation of GPS satellites, which rely on precise time measurements to provide accurate positioning data. These real-world examples of time dilation show that the flow of time is not uniform and can be altered by extreme conditions. Section 7. Paradoxes in time travel, the grandfather paradox. Time travel may be theoretically possible, but it comes with its own set of mind-bending complexities, particularly in the form of paradoxes. One of the most famous and perplexing of these is the grandfather paradox. The paradox arises from the possibility of altering the past in such a way that it creates inconsistencies in the timeline. Imagine a time traveler who goes back to the past and inadvertently prevents their own grandfather from meeting their grandmother. As a result, the time traveler's parent would never be born, and consequently, the time traveler would not exist. But if the time traveler does not exist, then who went back and prevented the meeting? This creates a logical contradiction, where the very act of time travel negates the possibility of its own occurrence. The grandfather paradox serves as a compelling reminder of the intricate and often unfathomable consequences of tampering with the past.
Section 8. Current research and future possibilities.
While the concepts of time travel and wormholes are steeped in theoretical physics, current research is making strides towards understanding their feasibility. Scientists are exploring the boundaries of our knowledge, delving into the complexities of space-time and seeking ways to test these ideas experimentally.
This research often involves advanced fields such as quantum mechanics, string theory, and the study of black holes. One area of active investigation is the search for exotic matter. Physicists are exploring various quantum phenomena that might mimic the properties of exotic matter, potentially providing the key to stabilizing wormholes.
Additionally, studies of black holes and their singularities are shedding light on the extreme conditions under which space-time might be manipulated.
Though we are still far from practical time travel or traversable wormholes, the progress being made in theoretical and experimental physics holds promise for the future. Each discovery brings us closer to unlocking the mysteries of the cosmos, fueling our imagination and driving our quest to explore the unknown.
Section 9. Fun facts and speculative scenarios.
While the science of time travel and wormholes is complex, it's also filled with fascinating tidbits and speculative scenarios that capture our imagination. For instance, did you know that time travel might already be happening on a very tiny scale?
Particles called muons, which are produced when cosmic rays strike the atmosphere, live longer than expected due to time dilation effects as they travel at high speeds. This extension of their lifespan is a small but real example of time travel in action.
Another intriguing idea is the concept of closed time-like curves, or CTCs, which are paths through space-time that loop back on themselves. If such paths exist, they could theoretically allow for journeys into the past and future, creating a self-consistent timeline where events are predestined.
This idea has been explored in various science fiction stories, such as in the movie Predestination, where characters' lives are intertwined through a series of time loops.
Speculative scenarios also abound in the realm of wormholes. Imagine a civilization advanced enough to create stable wormholes, using them to establish an interstellar highway network. These fun facts and speculative ideas highlight the boundless potential of time travel and wormholes. Section 10. Conclusion. Encouraging curiosity and exploration. As we conclude this cosmic adventure through the realms of time travel and wormholes, it's clear that these concepts, while deeply rooted in theoretical physics, are also fertile ground for the imagination. They challenge us to think beyond the limits of our everyday experiences and explore the profound mysteries of the universe. The allure of time travel and wormholes lies not just in the promise of adventure, but in the questions they raise about the nature of reality itself. Each new discovery in physics, each piece of evidence gathered from the cosmos, brings us closer to unraveling the secrets of time and space. Whether through the pursuit of exotic matter, the study of black holes, or the exploration of quantum mechanics, the quest to understand time travel and wormholes continues to inspire scientists and dreamers alike. So, as we look to the stars and ponder the mysteries of the universe, let's keep our minds open and our imaginations soaring. The ultimate cosmic adventure awaits, and with it, the potential to unlock the very fabric of reality.